Greetings ladies and gentlemen, this is Freddy Madonsela and welcome back to my channel. Last time we discussed differentiation of product rule, chain rule and quotient rule. Today we'll be discussing the derivative of a trigonometric functions. When we speak of trigonometric functions, we speak of our functions such as sine, cos, tan, cot, sec and cosec. Now, when we derive these functions, these are what? These are what? F at x. So, since it's our f at x, when I derive my f at x, I'm expecting to get what? My f prime at what? At x. Which is, this is my what? My derivative. So now, when I derive my sine, I'll get what? I'll get what? A cos. But now that cos, it goes with what? With the derivative of a function and the what? And the function. Whenever I'm having a what? I'm having a trigonometric function, I'll always have a what? A sine. I'll always have a what? A function. So in grade 12, you know that you'll have maybe your sine 45 degrees. But now, in this case, we won't deal with what? With degrees, we'll deal with what? With functions. So that's why I'm saying whenever I derive these trigonometric functions, I'll have what? I'll have a derivative. So now, looking at the table that I've drawn here, or that I've written here, is that whenever you derive sine, you'll get what? The derivative of your function, cos function. And when you derive cos, you'll get a negative derivative of your function, sine and what? And f at x. So now, you see the interchange. Whenever I derive sine, I get what? Cos. And when I derive cos, I get what? A negative sine. Then, when I derive my tan function, I'll get what? The derivative of what? Of cosec squared and the what? And the function. Etc, etc. Even when I'm doing what? Cot. I'm having a cot, a function, which is equal to a negative of a derivative of my function, cosec squared and what? And the function. And these ones, etc, etc. So now, whenever you write, bear in mind that you all know the derivative of what? Of these functions. Some lectures, they give you what? A formula sheet, but sometimes you have to know these by heart. So, if you could memorize this and know this by heart, then you'll be able to derive anything. But now, in the derivative of trigonometric functions, we're still going to continue use a product rule, quotient rule, and a what? And a chain rule, depending on how is the function. So now, I was giving an example. Let me say sine squared x. To not confuse this, you can say you are having sine x what? Squared. So since you are having a what? A squared. So now it tells you something. It tells you that you need to derive using what? Chain rule. Remember, with chain rule, you first derive the what? The outer part before you derive the what? The inner part. So now, in our case, we are having sine x squared. So to derive this, I will say the derivative of sine squared is what? I will first derive my outer part. So I will take this as my what? As my function. So I will say sine x. But now because I had squared, so that means here I'm having a quotient of what? Of 1. So I will have 2 multiplied by what? By 1. Because I had squared, then I will minus 1 from my what? From my index or my exponent. So I will have this. Then multiply. So now, because of I was differentiating my what? My outer part, now I have to differentiate what? My inner part. When I differentiate sine, I get what? I get what? Cos. I get what? Cos. But now, what is the derivative of x? So I'm saying I'm having a function which is equals to what? Is equals to x. And the derivative of x is what? Is equals to 1. Why? Because here I'm having 1. 1 multiplied by 1 is what? Is 1. Then I subtract 1 from my index, I will have what? I will have 0. So I'm having x to the power 0. And which is equals to what? 1. So 1 multiplied by 1 is what? Is 1. So that means here, because I was differentiating what? Sign. So that means I will have what? Cos x. So now, what you see, here I'm having my what? My derivative, which is what? Which is 1. And I differentiated sine to what? To cos. Then I'm still having my what? My function. So coming back here, you are having what? Sine of a function is equal to, when now you derive this, you get the derivative of your function, cos and your what? And your function. This is the derivative of a trigonometric function. Let's take a second one. So when I take a second one, I will say, if I check, I'm having a what? I'm having a positive. So that means this is the sum of, I'm deriving my what? My sum. Then it's simple. I can say y prime, which is my derivative. So I will first derive what? This part. I will first derive my what? My sine. So when I derive sine, what do I get? I get what? Cos. Cos 3x. So you see, I've derived sine to what? To cos. And I still kept my what? My function. But now, what is the derivative of my function? So when I'm having 3x, the derivative of 3x is equal to what? To 3. Using the same principle that I was explaining here, that since I'm having x to the power 1, then I will say 1 multiplied by what? By 3, then I get my 3. Then when I subtract 1 from my index, I'll get what? I'll get 0, which is equal to what? 1. So that's why I'm having what? 3. So that means here, my derivative of a function is what? Is 3. Then I come in, I say what? Plus. Now I'm deriving cos. So when you derive cos, you'll get what? You'll get a negative sign. So this is my what? Is the derivative of a what? Of a function. So that means I'll open my bracket and say a negative sign. A negative sign of a function. My function is what? Is 3x. But now, what is the derivative of 3x is what? Is 3. So now you are having something like this. To write this in a correct order, then you'll say, I'm having 3 cos 3x. Positive multiplied by a negative, I will have what? A negative 3 sine 3x. So now, I can also take out a common factor, which is 3, or you can also leave your answer here. So if you take out a common factor, you say is 3 cos of 3x minus what? Sine of what? Of 3x. Then this is your what? Is your final answer. So for now, we're done with the derivatives of a trigonometric function. So I thank you.